Hi, welcome. In this video, we'll solve problem reorder list asked by companies like Amazon, Microsoft, Google, Apple, and Facebook. Now let's solve one more problem on linked list, that is reorder list. Okay, we have solved so far how to reverse a linked list. So this is a little bit enhancement on reversing a linked list. Okay, although all the concepts will be same, and we will see how we can tweak some of the concepts and solve this problem. So what is this problem? So you are given the head of the singly linked list. The list can be represented like this: L0, L1, Ln minus 1, Ln, and so on. We need to reorder such that L0 will be first, then Ln, the last node. Okay, so zeroth node, the first node, the last node, then the first, you can say this is the first node and the second last node, right? Similarly, L2, Ln minus 2. Okay, you may not modify the values in the list nodes, only nodes themselves may be changed. So we can't modify it. Basically, you can create an array and you can modify it, but we won't do it. Okay, so here are few examples like 1 2 3 4. So this is linked list basically. So you can see L0, L1, L2, L4, L3. So L0 will come with L3, then L1 will come with L2, right? So this is how it will represent. Let me show you. Let's understand the example in a much more better sense. So we have this linked list, right? Suppose I am creating one, and this is 2, 3, and 4, right? And let me make a connection. This is my linked list. Okay, this is my L0th node, L1 node, L2, and L3, right? Now what I need to do, I need to break this connection, okay, and I want to join this with the last node, right? And this 2 will be 3, but this 4 will join the second, right? So this address was null as of now, right? So this address was pointing to null, but it should not be null. Okay, it will connect to this, right? So the overall picture will be something like this: one, then we have by 1, 1 will point to 4, then 4 will point to 2, then 2 will point to 3, okay, and then 3 will point to null, not 4. All right, so this is the structure of L0, then we have L3, then we have L1, and then we have L2. Okay, let's understand by one more example. Let's take a big example. Now let's see this example. So here you can see we have 10 nodes, right? Here you will get a complete understanding, right? So 1 is pointing to 2, 2 is pointing to 3, and so on till 10. Okay, so what we need to do, we need to connect the first node with the last node, right? So I will break this connection and I will connect with this last node. So I will connect with this one. Okay, and the last node will not point to null, it will point to the second node. Sorry, will point to the second node, right? Then second will not point to third, it will point to again the second last. Then this will point to again to third, and third will point to again third last. Okay, then four, this will point to this one, then this will point to seventh, then this will connect to this one, and 5 6. So if I create it, it will something like this: 1 is pointing to 10, and now 10 is pointing to 2, then 2 is pointing to 9, then 9 is pointing to 3, then 3 is pointing to 8, and 8 is pointing to 4, and 4 is pointing to 7, 7 is pointing to 5, and 5 is pointing to 6, and 6 is pointing to null. So this is how we need to create the connections. Now let's see how we can solve this. So now let's understand with this example. Basically what we need to do, we have one node, okay, and let's suppose this is my current node, okay, and I want to connect this current node. Let me write it more clear. This is current node. I want to connect with the tail node, or you can say last node, whatever it is. Suppose I am calling this as tail node. So I want to break this connection and I want to connect with the last node. Okay. So for this, so for this, I want to remember this last node, right? So that's why I'm using one pointer tail that will point to the last node. Okay. And now I want to connect this tail node to the second node. But how I will remember, because I have already lost the connection. So before canceling this connection, right, before breaking down this connection, you need to store it somewhere. Like let's suppose this is temp, right? You need to store the current dot next to some variable that is temp, right? So that you can connect the tail unit. Okay, and this is done. Okay, now the next connection will happen, right? How it will happen? That here your 2 will break this connection and again it will connect to the second last, right? So for this to be happen, don't you think that your current pointer should move a bit forward, right? Because the same thing is repeating. Tail will move forward, but how this tail can move here in this direction? Because in a linked list, all these node store the address of the next node, right? So this node store the address of the next node, this node store the address of the next node, right? You can't move in this direction, you can't move in this direction, not possible, because the nodes have not address of the last node, right, the previous node. So you can't move in this direction, and that's the main problem, right? I can do this connection, right? It is very clear that I want to connect with this one. I will take one pointer here, I will take one pointer here. I will simply say current dot next equals to tail, and tail dot next equals to temp. What is temp? That is current dot next. Okay, but how my tail will move in this direction, right? How I will update it? Because for this, what I want my tail should be here, my current should be here, and again I will make the same connection. My current dot next will be tail, and tail dot next will be again the new temp that we have stored here. This cycle will repeat. Again I will update my current to this, I will update my tail to this. Okay, and similarly again we will create a connection, that is current 3 to 4, that is already there. Okay, and 4 to the temp, so temp will point to here. Okay, and your tail, like your 4 point to this itself, right? So what we will do for this? So we have, suppose this as a linked list, 1 2 3 4 5 6, right? Something like this. And how we will do it? 6 will be point to null. Okay, so what I will do, I want to move in this direction. My tail wants to move in this direction, right? My tail wants to move in this direction. Okay, and you can see, right, I am moving my tail till half of the linked list, till half of the linked list, right? Middle of the linked list, right? Tail is not moving till here, right? Till current. It is moving till half of the linked list. So that means I want a backward direction to half of the linked list, only half of the linked list, right? So what I will do is I will create a reverse of it. Okay, so if I create a reverse of it, how it will be? It will be something like this. Your 6 will point to this linked list 5, your 5 will point to 4, and your 4 will point to null. Remember, we have done this so far, right? Reversing a linked list, right? 4 will point to null. Okay, and you will get this as in head, right? And suppose that I have stored in my tail. So now we have a linked list something like this, right? We have reversed the half of the linked list. Again, please see the picture very clearly. Your 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, but 4 is pointing to null, right? Right, you have one tail pointer, right, and one head pointer, you can say, which I am denoting right now as current, right? And now what we can do, we can complete our steps. What I will do, I will say my current dot next equals to tail, right? So if I'm doing this, that means I'm breaking this connection and I'm connecting current dot next to this tail. Okay, then what I need to do next step, now tail dot next should be equals to current dot next, right? But we have lost this connection. So before doing this, what I will do, I will store in some variable, let's suppose temp equals to current dot next before losing this connection. So my temp will point to here. Okay, so now I can simply say my tail dot next will point to temp. Okay, now what I can do, I can move my current equals to temp, current equals to temp. So my current will move to here, and I want to move tail to the next step. So can I move my tail from here to here? No, because now tail dot next is temp. Tail is representing to this temp. So I can't move something like this. I can't say tail equals to tail dot next. So before breaking the tail connection, right? Before breaking this connection, because 6 was pointing to null, right? 6 was pointing to null, right? I have no, like 6 was pointing to this one, 5. I break this connection and now my tail is pointing to 2. I break this connection, I lost this connection. So before losing this connection, tail dot next equals to temp, what I need to do, I need to do one more step, that is I need to store my next pointer. So let's suppose I am creating tail next equals to tail dot next. Okay, so now what I can do, I can simply say my tail equals to tail next. So what is my tail next? This was my tail next. Okay, and from this my tail will point to here. And we will repeat these steps, right? Let's see the picture. Once I have done these steps, what will be the picture? So let me copy the notes, how much we have done. So tail, first of all, so these are simply tail next equals to tail dot next. So your tail next will be here. Temp will be current dot next. So temp will be here. Current dot next equals to tail. So current dot next, that is current was pointing to 1, equals to tail, that is equals to 6. And now tail dot next equals to temp, that means 6 dot next equals to the next node, that is 2. So it will point to 2. This is the picture so far. Okay, and let me clear this image. So this is done, right? After this, so clear the image. So let me just remove all these things. My current is pointing to here, temp is pointing to here, tail is pointing to here. This connection is broken. Okay, so current is pointing to temp, like tail is also pointing to tail next. 6, 1 is connected to 6, 6 is connected to temp. So that is, let me draw this line, something like this one. Now what I will do, I will do the same steps again. Tail next will be tail dot next, so my tail next will be here. Temp equals to current dot next, so temp will be here. Okay, current dot next equals to tail, so current dot next, that means this will break and it will connect to tail, right? Tail dot next, that means this will break and this will connect to temp, that means this will connect to here. Okay, and again my current will be on the temp, so my current will come here and my tail will connect to tail next, right? So if I create this figure, so let me create the nodes. Okay, so 2, now 2 is pointing to 5, then 5 is pointing to 3. Okay, and here as of like after this 3 is pointing to 4 and your 4 is pointing to null. So 1 is pointing to 6, 6 is pointing to 2, 2 is pointing to 5, 5 is pointing to 3, and 3 is pointing to 4, and 4 is pointing to null. Right? This is what we want, and this is how we can achieve. These all are the steps, right? And everything will be clear once you create a figure of it. So everything is on depending on the how you are reversing the linked list. You just need to reverse the half of the linked list. You just need to reverse the half of the linked list and the work is done. Right. So now how we will do reverse a half of the linked list. Let me show you. So again I will take the same example. So we have this as a linked list, right? And we need to reverse the half of the linked list. So basically what we will do, we will call our reverse function that we have created in the last chapter, right? Reverse, how to reverse a linked list. We will simply pass the middle node and it will give the half of the linked list. So how we will find the middle node? So we can use slow pointer and fast pointer technique, okay, to find the middle node. So how to find a middle node by slow and fast pointer? I guess you have checked the linked list cycle, right? We will do this exact same. So what I will do, I will take one slow pointer, okay, and I will take one fast pointer, okay. And remember, slow will reach one step, okay, and fast will reach two step. So when fast will travel two step and slow will travel only one step. So slow will at the middle when fast will be at the last point. Okay, because it is covering 2x distance, right? So basically, suppose there is a round trip of 20 km, okay, and fast is moving two steps, slow is moving one step. So if fast completed the complete distance 20 km, slow will only complete 10 km. That is the middle of the round, right? Same concept here. So like suppose after one node, slow will point to here and fast will point to one and two step here. And after again one more round, slow will point to here, your fast will point to here, right? Then slow will point to here and fast pointer will be here, not here, sorry, fast pointer will be here. Now fast is at null, right? So you can stop it, break it, and you will get the slow pointer at the middle of the linked list. Okay, you can try by even and odd. In all the cases it will be middle, right? So like 1 2 3 4 5 6, this is what I want this to be reversed. So now you can pass this slow pointer in your reverse function, okay, and then it will basically reverse it, right? You will use the same concept of reversing. It will reverse it, and how it will reverse it, basically it will reverse something like this. 6 5 will point to true and 4 will point to null. And the when you are doing reverse, it always returns the head, and that will be your tail of the linked list, right? So you will get this tail of the linked list, and now you can simply write these steps so that you will get a complete this connection, right? And this is how you can solve this problem. Let me write the pseudo code of it, okay, so that you will get a better clarity of it what I am saying. So what do we need to do? We need to take one slow pointer that is pointing to head. We will take one fast pointer that is also pointing to head, and we can take one current pointer that is also pointing to head. Now the first goal is find the middle of the linked list, right? Middle node. Okay, we need to find middle node. So for middle node, what we will do? We'll run a loop. Okay, while fast not equals to null and fast dot next not equals to null, because fast is moving two steps, so fast dot next can also be a null. Okay, so slow pointer will move only one step, slow equals to slow dot next, and fast pointer will move two steps, so fast will be fast dot next dot next. Okay, so this is done, right? You got the middle node, right? and your slow will be your middle node here. Okay, now what you need to do, you need to find tail by reversing the half of the linked list. How you will find tail? Basically you will call the reverse function with slow. And what is your reverse function? Okay, we have already solved it. Basically we will use one current before and after, right? One current previous and after, right? By using three variables we created. Once you have done it, right, we just need to write down all these steps that we have done, right? So I will put this complete here, and this will be my steps that I need to do. But till when I need to do these steps, right? Here we were doing connections again and again. See, so you need to stop when your tail, so this was your tail, right? Tail next, right? And now your tail next will be here something, right? Because from 6 to 5, 5 to 4, and 4 is pointing to null, so your tail next will be here, right? So once your tail is saying tail dot next equals to null, you will simply stop it there. Okay, so this will run till while my tail dot next is not equals to null. Once my tail dot next is equals to null, that means I need to stop it, right? We'll do a dry run of it. Okay, we will do a dry run of it, but before doing this, let's quickly check the time complexity of this code. So here you are simply saying slow equals to head, fast equals to head, current equals to head. Then you are running middle nodes, so you are just finding a middle node. So this will take something n by 2, right? Because fast is pointing 2 steps, and this loop will terminate till half of the linked list. So I will say this will take n by 2 iterations only. Now you are reversing a linked list, right? So you are also reversing a half of the linked list, so this will also take n by 2 operations, right? And now once we reversed it, this loop will run till my tail is not getting tail dot next, right? So again this will also run n by 2, because we will running current pointer and tail pointer, right? So all these are n by 2 n by 2 operations, right? If I simply sum it, so it will be something 3 n by 2, which is again this is a constant, so the time complexity will be big O of n only, right? And talk about the space complexity. So we are doing reversing by a simple iterative method, right? We are not using recursion, so there won't be any auxiliary stack memory. But again, you are open to use any type of method to reverse a linked list, right? You can use recursion, you can use iterative methods, it's up to you. Like here we have used the iterative method, so space complexity will also be constant, it will be big of 1. Okay, so in the next video we will see how we can implement this code directly, and after this then we will check out the dry run of this code.